Now, to diagnose a no-start situation, there's certainly some tools that you'll need. Many of them are just commonplace tools you should have, and there's a few luxury tools as well. Let's go over to the table and I'll show you what I have. Okay, you certainly should have a DVOM, a digital volt ohm meter, good test light, one of these little test spark plugs that you just ground on a piece of metal and hook your plug wire on the end and then check to see if you have a spark. You can get that in pretty much any auto parts store. A Noid light. This is a kind of an older style Ford Noid light. Here is a newer one. You can hook right into an injector wire and see if it flashes to let you know that you're getting a signal from the PCM. Here's a little jump wire that you can hook right on the injector. Then you have your two ends here that you can hook a ohm meter to see if you have an open circuit, something like that, in your injector. You should have a fuel gauge for a fuel injected system. This is a mechanical gauge. I have an electronic gauge that I'll likely use on this project during the video. Here's a spark plug boot remover. This is a real kind of nice elaborate one. Actually, it doesn't work that great. I have trouble with the plug wire getting kind of interfering with this part of the tool. Some of the cheaper ones that look just like a pair of pliers that have little rubber tips on the end, they do a pretty good job. I have this TFI that I made that has a hard shell hooked to it, 3 wires going to it. It can be used to start a car that has a bad TFI module. As long as the TFI module is not too shorted up and completely destroyed on the inside, most of them just go to an open circuit when they fail. You can actually plug this in. You plug this in to your TFI that's on the distributor, and you hook your harness into the other end, and the engine will usually start as long as the stator in the distributor is working. Now, you can't go too far because there's no heat sink here and the thing will tend to run a little bit hot, but it'll get you off the road or maybe get you to a garage so you can actually work on the car. Now, here's a code reader. Now, this happens to be a kind of an expensive one, has a nice little display on it, but you can buy them pretty inexpensive. There's really no excuse not to get one now. There is a way that you can use a test light and some jump wires, and you can get read codes by reading the blinks on your test light. I feel though that there are some code readers that are so inexpensive now, there's just no excuse not to get one of those. Now, over here I have a few luxury items. This right here, it's actually a pretty old tool. It's used to check your map sensor or the barometric sensor. Those sensors put out a frequency. So by hooking this into a DVOM, it changes that frequency in a voltage so you can read it on a regular DVOM. It does a pretty good job. This right here is a TFI tester. You just plug this right into your distributor, and these little lights on the top will blink when you turn the engine over, and if one of them is not blinking, it will tell you which component is bad. It'll tell you if the stator is not working or the TFI or both. I think this is still available from Ford. It does a pretty good job. This right here is a laser type remote temperature probe. Has a little laser beam that comes out. It's real good. A lot of diesel guys like to use it when they have a miss in the engine. You can aim that to each individual header pipe next to the cylinder head, and the one that has a lower temperature is likely the cylinder that's misfiring. Okay, what is needed to get the engine to start? You need 3 things. You need compression, you need fuel, and you need spark. Now, the compression is, obviously if the car has been running before and you just went in to, like I say, eat lunch and you came back out and it doesn't start, well, it's probably not compression, the thing had been running before. But what if you were at the drag strip and you were in high gear and you're wide open throttle and all of a sudden you heard a pop and the engine cut off? Then when you went to start the engine, you turn it over, man, it spins over real fast, sounds like there isn't a piston in the block. Well, it's a very good chance that you broke the timing chain or you broke the camshaft in half. If that's the case, you should be able to take your distributor cap off, spin the engine over, and see if the rotor is turning. If it's not turning, well, you probably broke a timing chain. If it is turning, then go ahead and turn it until you hit top dead center on your crank pulley down there and see where your rotor is. If it happens to be 180 degrees away from the number one tower, well, you're all right. You're probably just on the exhaust stroke. So spin it one more rotation until you get to TDC again on your crank pulley, and then see if the rotor is pointed near the number one tower on the distributor cap. If it is, most likely, you didn't mess up anything on your camshaft. And if you still had a concern, maybe thinking something's not just right, it feels like this, it sounds like there's no compression or something, well, put a compression gauge on a couple cylinders and see if you have, some pressure there. If you've been cranking and cranking and cranking and the thing hasn't started, and sometimes you've cranked so long that you'll actually hear the engine squeaking, what you may have done is washed all the oil off the cylinder walls, and now it definitely doesn't have any compression. So you need to pull your spark plugs out and check they may be all fuel fouled. Clean those up, and you may squirt a couple squirts of oil down each spark plug hole. Put it all back together, and of course you'll still need to find out why it doesn't start. So I think once you've determined it's not compression, and you've got an engine that it's a known good engine. Of course, if you had an engine that you had no history on and you're getting it from a wrecking yard and you're starting it for the first time, well, you may want to look at that area a little closer. But let's assume the compression part is okay. So you have fuel and spark next. Well, on a fuel injected engine, it's easier to check the ignition before you check the fuel. Because after all, in the old carbureted cars, if you wanted to check to see if you had fuel, all you had to do was take the air filter off, stick your face over the, throttle plates, hit your, gas pedal, and you should see fuel squirt from the accelerator pump nozzles. And if you do, well, you have fuel in the fuel bowl, you have, some fuel pressure. Well, you can't really do that on a fuel injected car. So it's easier to check the ignition. And by the way, it makes more sense to check the ignition next anyway, because if you have lost your ignition system, most likely the injectors won't be firing either, since it gets its signal from the the ignition or from the distributor. So the first thing, easiest thing to do is just to simply take your coil wire off of the distributor cap and put one of those dummy spark plug test plugs in, and we'll see if you have a spark. Okay, let's install it. I'll take the coil wire off the distributor cap, plug it into my little test spark plug, and I'll stick it right here to ground it, and then we'll spin the engine over and see if we have a spark. Okay, we got spark all right. It might be a good idea to go a step further, and that is to put the coil wire back on the distributor cap and then take one of the spark plug wires off and put that dummy plug on it to make sure it's coming through the cap into a spark plug wire. If it doesn't spark there, then you might have a bad rotor button, there may be a cracked cap, something like that. All right, say we didn't have a spark here. Well, maybe I have a bad coil wire. If you have another coil wire that you can test on there, try it again. Sparks then, you probably have a bad coil wire. Still doesn't spark, then the next step is to check at the coil. What we want to find out, does the coil have voltage going to it? So I'll get my test light, I'll take the little clamp, hook it on the ground of the battery, make sure the test light's working, and then I'll put it on the hot side of the coil and turn the key on. Key is on, put the test light on the hot side, and you can see it lights up. If it didn't light up, then we have an open in that circuit, somewhere between the coil and the ignition switch. You may need to take the little sight shield, you know, the trim off the bottom of the steering column and probe this same wire on the ignition switch with the key on. And if it's not hot there, most likely you have a bad switch. All right, we do have light there. So now we want to check the ground side of the coil. Go over here and you can see that's also lit. No problem. And it should be. If it's not lit, there's one more test you need to make, and that is to spin the engine over and see if it blinks. So we'll try that. Let me see if I can mount it in position and then spin the engine over, see if it blinks. Okay, key off, and that checked out. It blinked like it should. Now what if we were hot on the hot side and we had no voltage on the ground side and it did not blink when I turned the engine over? All right, most likely you have an open in the coil, in the primary windings of the coil. Get a known good coil, put it on there, test it again. It will likely work just fine and the engine will start. But let's say you did have voltage on the plus side and you had voltage on the minus side or the tack side, and when I spun the engine over it did not blink, it just stayed on. Now you're likely having a problem with the distributor end. It's either the TFI or the stator inside, or there's a break in the wire from here to the distributor. So the next thing to check is the distributor. The first check I'll make on the distributor is to unplug the TFI module, and the third wire from the bottom up, which on this one is red with the green stripe, I want to see if that's hot with the key on. Okay, it's lit up. Now that same wire, that third from the bottom, is the wire that's also going to the hot side of the coil. If it was hot at the coil but not here, then there's a break in the wire and that needs to be checked. If you, of course, get to this point and that's hot, most likely you have a bad TFI or you have a bad stator inside the distributor. If you thought maybe it's just a TFI, you could put that little jump TFI that I made, where you plug that into the old TFI and then you plug the engine harness into the test TFI and then see if you have spark and the engine should start. If you don't have one of these, then just finding another TFI or buying another TFI and simply bolting it in place and then see if it works. Remember, anytime you replace these TFIs, you need to put some dielectric grease on the back to transfer the heat. All right, if you do that and it still doesn't start and it still doesn't spark there, most likely you have a bad stator. Now there's not a really good way of checking the stator other than to simply replace it. And to replace a stator, of course, the distributor has to be completely disassembled. It might be easier just simply to get another distributor. Now if you have that Ford test tool, then you can find out which component is actually at fault. So we'll use that tool now and see what we have. And I'll take the tester and I'll plug it into the TFI on the distributor, just like that. And also this tester is made for testing remotely mounted TFIs. Now this is the connector that would go into the distributor on those. Many of the latest versions of the EEC systems had remotely mounted TFIs. The other wire here hooks to the battery. Now this will go to the hot side of the battery, not the ground, the hot side. Now I'll spin the engine over and see if we have some lights blinking. Now you may not have been able to see it in the video that easily, but I definitely had blinking lights. Now the way you evaluate this tester is you see what is blinking. On this car, of course, both lights were blinking. We know this one is working properly. If the left one, which is the PIP light, was blinking and the right one was not, that's the tack light, then most likely you have a bad TFI module. If neither light was blinking, then you likely have a bad stator. And if you have a bad stator and need to replace that, I would say replace the TFI as well. If you only have a bad TFI, normally you can just replace that and you will be okay. Now what if you made this test and your distributor passed the test with no problem, yet you weren't getting a tack signal on the ground side of the coil? Well, it could be that your tack lead wire, which that's the second from the bottom on your TFI hard shell, is open somewhere in that harness. So you could take an ohm meter and probe from that second from the bottom wire over to the tack lead connection on the hard shell on the coil. And you should have continuity. If it's an open circuit, obviously you have a break in the wire somewhere. If that checks out okay, there is one other thing that you could have going on, and that is the spout wire might be shorted. What you would want to do is to plug it all back together, have your dummy spark plug back in, and take your spout shorting bar off, pull that little shorting bar off, or on the older model ones it's actually 2 wires, you have to unplug it, and then see if the engine starts or see if you have a spark. If you do, and you can get the engine started and you plug that back in and suddenly the engine cuts off or starts running super ragged, there's a chance there is a short in that wire, or there may actually be something wrong with the PCM. It may come down to replacing the PCM if you determine that that wire is not shorted. Okay, let's say you checked everything out and the ignition is fine. You have spark, you don't see any problem there, good strong spark at your coil, you've maybe checked a couple of your spark plug wires and you had spark there. Then most likely you have a fuel problem. First thing to do, check to see if you have fuel pressure. So we'll do that now. Now most systems will have a Schrader valve connection. If it doesn't, there are adapters that are available that hook into the fuel line where you can plug in a gauge. I do have a Schrader valve on this one. And then I'll plug in have an electronic fuel gauge. And when you first plug it in, you'll have likely 0 pressure because you've released it when you put the Schrader valve connection on. So we'll have to cycle the key. I'll cycle the key on. And you see the pressures went up to 35.5, something like that. It's dropping, but it's dropping very slow. That's really what you want to see. That's a good reading. If the pressure went up to say 30, 35, 40 pounds, and then as soon as the pump cut off, the pressure went right to 0, then you might have one of 3 possible problems. One is the check valve may be bad in the fuel pump. If that's the case, normally that doesn't cause a no start. That may cause a long crank time, but then once the engine starts, that check valve goes open anyway, and you'll be fine. Another thing is the pressure regulator may be leaking. Again, may cause a long crank time, but usually the engine will still start and the pressure will maintain once the pump comes on. You can verify if you have a bad pressure regulator leaking by simply plugging off that return line. If the pressure goes up then and then doesn't fall, then you have a pressure regulator that's leaking. The third thing is you could have an injector leaking. Now, of course, if you've had an injector leaking and that pressure dropped way off real quick, you've got a really bad situation, because that means that fuel from that injector is pouring on into the intake, going down in the cylinder. It's very easy for it to hydraulic the engine. The cylinder will actually fill up with gasoline and lock the motor. That's very bad. What you want to see is the pressure go up and stay fairly stable. Now, if you didn't see a reading like that, say the pressure didn't come up at all, then you can suspect that you have a bad fuel pump. Or you might have an inertia switch that's either tripped or open. So we need to go back to the trunk and we'll check that area. The first thing I want to check is to make sure that the trip switch is pushed down, which it is. And then I took some insulation off of one of the wires here that's going to the switch, and I'm going to cycle the key, and the light should come on and then turn off. And we'll look for that. Okay, that's what we want to see. Then I should check the other wire as well, and it should do the same thing. If one does and the other one doesn't, you have a bad inertia switch, and that'll have to be replaced. If both of them come on, then you should have voltage going to the fuel pump. If the pump's still not giving you pressure, most likely you have a bad pump, or there's an open in the wire between the inertia switch and the fuel pump. Now understand, this inertia switch is in series with the pump. On units that have the inertia switch tied into the primary side of the fuel pump relay, then anytime the key is on, both of those wires should be hot. Alright, let's say neither light lit up. We have to find out why we're not getting current here. Therefore, the next thing to check is the fuel pump relay area. Now understand, when we probe that wire back there at the inertia switch, when you cycle the switch, the light comes on and then it turns off. The reason it turns off is it's waiting for a pip signal. If it doesn't receive the pip signal, in other words the engine turning over, it just simply shuts the fuel pump relay off. Now there's a way to turn the pump relay on without cycling the switch. You just simply turn the switch on, then go over to the self-test connector and ground this terminal. You ground the terminal, the light should come on. The fuel pump should come on at the same time. When you unground it, the light should go out, turning the pump off. Remember, this is the same wire that's going to pin 22 of the processor. That's the wire that grounds, turning the fuel pump relay on. Okay, let's say that we still don't have current back there. Now we need to go to the fuel pump relay and check that. Now, of course, my pump relay system is out here where it's easy to troubleshoot it. The first thing we want to do is to see if the wire that's supposed to be hot all the time is hot. And in this setup, it's this wire right here, and you can see that it is hot. Now, if you don't have one of these relays like I made, you have the regular, conventional hard shell that any EEC system would typically have, like this one right here. What you want to do is to probe the wire at this location. Don't worry too much about color codes because that changes from year to year. But this is the location that you would probe to see if that wire is hot. Then you want to turn the key on and see if the wire that goes from pin 37 and 57 is hot. That'll be hot with the key on, and it'll be off or no voltage with the key off. On my system, it's this wire right here. So let me turn the key on, light comes on, turn the key off, and it goes off. Now, if that light doesn't come on, then you may have a bad EEC power relay, because after all, that's where that current is coming from, the EEC power relay. On the hard shell connection, this is the location of that pin. Okay, now when we cycle the switch, we should see the output part of the relay come on and go off, just like we saw back there at the inertia switch. So let's try that. On, went off. Okay, on the hard shell connector, this is the wire that would be hot when you cycle the key on and then turn off after a few seconds. Now the other wire that we want to check is the trigger wire. Remember, this is the one that's coming from the PCM pin number 22. Same wire that's going to that self-test connector. When that one grounds with the key on, it makes the pump come on. So I'll turn the key on and then probe that connection with the test light. It will ground it. That's this location, and you may be able to hear the pump came on. Undo it, pump went off. There's enough low resistance in the bulb in the test light that essentially this is somewhat like a ground wire. Now, if you don't have a test light, of course, you could just use a jumper ground wire to that pin and it should make the pump come on. This is the location of the wire on the hard shell. Now, if that didn't turn the relay on by grounding it, most likely you have a bad pump relay. You need to replace it. Try it again. All right, let's recap this fuel system just a little bit. Put your gauge on there, turn your key on, you don't have fuel pressure. Go back to the inertia switch, see if you have current on both sides of the wire. If you do, and you have the inertia switch that's mounted in series between the pump relay and the pump, then you should have fuel pressure. And if you do have current on both of those wires and you don't have fuel pressure, then most likely you have a bad pump, or there's an open in the wire between the inertia switch and the fuel pump. All right, let's say you don't have current on the inertia switch. Then you go up to the fuel pump and see if you have current on that wire that should be hot all the time. If you don't have current there, you don't have voltage, you may have a fuse link that's burned out. So that'll have to be checked. Say that's okay, and then you turn the key on and you check the wire that's going to the 3757 pin. Should be hot with the key on. If it isn't, then you may have a bad EEC power relay, because that's where that voltage is actually coming from, and you may have to replace the relay. If you cycle the switch and you go to the output side of the fuel pump relay and you don't get current, then you want to ground that the number 22 pin, you know, the one that's actually going to the self-test connector, and it's going to the 22 pin of the PCM. If you ground that and then the pump relay comes on and you have current on the output side, but you don't have it when you cycle the key, you either have an open in the wire between there and pin 22 of the PCM, or you may have a bad PCM. All right, let's say all this checks out okay. You do have fuel pressure, and you have ignition, but you can't start the engine. Well, the next thing we want to check is the injectors. We want to see if the injectors are firing. So the first thing we'll do is we go over to one of the injector hard shells. Okay, the very first thing I want to do is to turn the key on, take my test light and back probe the red wire on one of the injectors, the one that's easy to get to. Let me back probe that, and I get a light coming on my test light. That's letting me know that the EEC power relay is working. If the light did not come on, then we may have a bad EEC power relay. And if that's the case, we would have caught that back when we were testing the fuel pump. Okay, the light comes on, okay. Now we want to see if we have injector pulse. The best way to do that is to put a Noid light on it. So we'll unhook the hard shell, and I'll plug a Noid light in. Now I'll go inside and turn the engine over and see if I have a pulse. That's what I want to see, a pulse. All right, well, what if the Noid light didn't pulse? There is one sensor on the engine that could cause the injectors not to pulse, and that's the throttle position sensor. If for some reason it was stuck in the wide open throttle position, or electrically it's damaged and it's sending a signal that it's wide open, it would put the processor into what they call D-choke, and it shuts the injectors off. Just like on old carbureted cars, if you thought the engine was flooded, what did you do? You put your foot all the way down on the throttle, and that would open the choke, clear out the engine, and hopefully it would start the engine. Well, on an injected engine, it does the same thing. If it sees that the throttle is wide open, it shuts off the injectors, hopefully being able to clear out a flooded engine. So if you suspected that that might be the case, you could back probe your throttle position sensor and see what the voltage is. If it was like 4.5 volts, that would signify probably a wide open throttle. But it's an easier way than that to check. Just simply unplug it. If you unplug it, the processor will go to a kind of limited strategy. It will know that it's an open circuit and the injectors should pulse. So unplug it, try it again. If it pulses, then most likely you have to replace the throttle position sensor. If you're still not getting a pulse, then it could be that the PCM is not getting the pip signal from the TFI. And there is a wire that's going from the TFI back to the processor that lets the engine know, lets the processor know that the engine is rotating and it's time to pulse the injectors. If that was an open circuit, of course the injectors would not pulse. That would need to be checked with an ohm meter. If that checked out okay, then it's very likely you simply have a bad PCM and you will probably have to replace it. Put that in, recheck it, you have pulse, the engine should start up.